Good afternoon, dear viewers, and welcome to the CEC's live lecture for the science stream. I know you eagerly await our lectures, which talk about very interesting topics that have relevance to industry and academia. Today also we will be talking about one such proliferative and progressive field of big data. You have been with us for 5 past lectures that have been talking about big data, the analysis, their applications, and how machine learning can be used to analyze big data in the previous lecture. So today we will welcome in our studio Dr. Kashish Ara Shakil, who will be talking to us regarding big data analytics, Hadoop, and HDFS. So welcome, Dr. Kashish.
Hello, dear listeners. So today we will be talking about the architecture of Hadoop, and then we will be talking about one of the very important component of Hadoop, which is HDFS, that is Hadoop Distributed File System. So let's begin with Hadoop. Basically Hadoop is an Apache project, and it offers the users with a scalable, flexible and reliable distributed computing big data framework. So what it is that it provides you with a framework for management of big data, and this framework is very scalable in the sense it can handle any amount of data. So if the user's demand for data goes up, this framework can handle that increasing demand, and if the demand is decreasing, then also the framework will be able to handle this demand. And this framework is also flexible to the different demands of the users, and then it is also reliable in the sense it provides data storage in multiple factors, that is it replicates the data in different nodes. So in this terms, the data which is being handled by Hadoop framework, it becomes more reliable. And it is basically used for managing big data, and this data is managed across a cluster of computer systems. So there is no mostly if you are going for a mode which is a distributed mode, we will be talking about the different modes in which we can set up Hadoop later on in today's lecture itself. But if you are going for distributed mode, in that case the data will be managed across a cluster of systems, and these systems, they will be having some storage capacity as well as some kind of local computing power. And for all offering these kind of computing powers, these kind of storage capacity, the users, the framework which is being used, that is Apache Hadoop, it will be leveraging the use of commodity hardware. So what commodity hardware is? The hardware which is already available at a particular location. So by using this hardware, they will be able to cater to a range of services, they will be able to cater to a large number of customers. So Apache Hadoop is a software library, and it is a framework which allows the processing of data in a distributed manner, and it allows processing of very large data sets across clusters of computers using a very simple programming model. So that programming model is MapReduce, which also we will be discussing in the upcoming lectures. So it is a framework that allows processing of distributed rather it allows processing itself in a distributed manner using a large number of clustered computers, and it is designed to scale up from single servers to thousands of machines, and each of the machines, they offer local computation and storage. So just like I just talked about scalability, Apache Hadoop, it can scale up to handle it can basically, if you have just a requirement for a single machine, then it will be catering to your requirements using a single machine itself. But as and when your requirement increases, the framework itself will be able to scale up to thousands of machines and meet your requirements. So this is how Apache Hadoop works, and you as an end user, you do not have to worry about the scaling up, scaling down. All these activities, all this management of scaling up, scaling down will be handled by the Apache Hadoop framework itself. Rather than relying on the hardware to deliver high availability, the Apache Hadoop library itself, it is designed to detect whether if there is any kind of failure which is occurring. So rather than relying on a single hardware, which we normally do in our normal programming framework, what Hadoop does is it will distribute the programming onto multiple machines, and the framework itself will be able to detect that if a particular node fails, if a particular machine fails, then in that case the framework will automatically start up another machine which is connected on the cluster, so that this failure is handled. Hadoop, it basically follows a master-slave architecture for transformation and analysis of large data sets using something called as Hadoop MapReduce paradigm. So Hadoop MapReduce paradigm is for processing part. What it is exactly, that we will go into the depth in the upcoming lectures. So Hadoop, for the time being, we can say that it just follows a master-slave architecture, where one of the nodes, it will act as the master, and other nodes, they will act as the slave nodes, and then they will be performing processing of large data sets in parallel, and all these distribution of data across different machines which are connected, which are running in parallel, all this is taken care of by the Hadoop framework itself. So the users of Hadoop, they do not have to worry about distributing the processing. Everything is taken care of by the Hadoop framework itself, and then on these distributed machines, MapReduce programs will be run, through which the processing also will be taking place in a distributed manner. So there are different many important components of Hadoop project itself. So the different components of Hadoop project, it comprises of, first we have Hadoop Common. Hadoop Common, basically it comprises of all the common utilities that support the Hadoop modules. Then we have Hadoop Distributed File System. So just like we have file systems in Linux, similarly we have a file system in Hadoop, which is called as Hadoop Distributed File System. It provides high throughput access to the application data, and what it does is it stores the data in a distributed manner. So this distribution, this storage in a distributed manner, what it does is it ensures high reliability and high availability, because the data, usually the data is replicated, and I think by default Hadoop framework has a replication factor of 3. So whenever you are storing any data on Hadoop, this data will be stored into 3 multiple copies, and whenever one machine goes down, which is containing the server, which is containing the data, the other machine will automatically back up, and then high availability is ensured through Hadoop Distributed File System. Then another very important component of Hadoop is Hadoop Yarn. It stands for yet another resource allocator. So what it does is it is a framework for job scheduling and management of cluster resources. So all the management work will be done by the Hadoop Yarn component of Hadoop. Then we have MapReduce, which we can say is the heart and soul of Hadoop. It is a yarn based system for processing of large data sets in parallel. So what it does is it will perform all the distribution of your large data sets using mapper component of Hadoop MapReduce, your data will be distributed across different nodes, and then we'll be running on the reduce part of the program, which will be combining together all the processing which was done on parallel nodes. So these three are rather four, these four are very important components of Hadoop, that is Hadoop Common, Hadoop Distributed File System, which is the backend, then Hadoop Yarn, which is the cluster resource management framework, and then Hadoop MapReduce, which is the processing framework for management of large data sets in Hadoop. Now let's have a look at how Hadoop ecosystem looks like. So in Hadoop ecosystem, at the bottommost layer we have Hadoop Distributed File System, which is a system for storage of the data in Hadoop. Then we have Yarn MapReduce, which is for the distributed processing. Then we have HBase, which is a kind of column based data storage system. Then we have other utilities like Hive, which is for querying purpose. Then we have R connectors, which are used for performing some kind of statistical operations. Then we have Mahout framework, which is for performing machine learning operations on top of Hadoop HDFS. Then we have Pig, which is a scripting language. Then for management of the workflows in Hadoop, we have Oozie. Then we have Zookeeper, which is for coordination. We will be going into the depth of these later on. Then we have Flume, which is for collection of logs. Then we have Scoop for data exchange. Apart from that, they are also responsible for import of the data depending upon the type of data into Hadoop ecosystem. Then we have Ambari, which is for provisioning, managing and monitoring of the Hadoop clusters. So now let's have a look at these components of the Hadoop ecosystem based on their functionality. So at the bottommost layer, that is for data storage purpose, we have HBase and we have HDFS. So HBase is for columnar database storage, and then HDFS, like we already talked about, is for distributed file system management. Then if we are going for data processing, then we have two things. We have MapReduce, which is for parallel processing and for cluster management, and then Yarn is the cluster and resource management part of the data processing of the Hadoop ecosystem. Then if we want to access the data which is stored in the bottom layer, that is HDFS or HBase, we need tools such as Scoop for data access of the type of data being relational. So for relational DB, it is for engulfing RDBMS kind of data, relational kind of data. Then we have our Avro for RPC and serialization. Then we have Mahout, which performs parallel processing on top of machine learning. So it performs machine learning in a parallel manner on top of Hadoop. Then we have Pig, which handles the data flow and it is a scripting language. Then we have Hive, which also performs data access using an SQL like syntax. Then we move on to the data management part. So for the data management part, we have different tools or different frameworks which are available, like Zookeeper. Then we have Flume for monitoring. Then we also have something called as Chakwa. Then we have Oozie for workflow monitoring. So these are the components of the Hadoop ecosystem based on their different functionalities. So the different functionalities, they include the functionality of data storage, the functionality of data processing, the functionality of data access, and the functionality of data management. Let's have a look at other related Hadoop projects which are there. Like we talked about Ambari. Ambari is a web-based tool for provisioning, managing and monitoring of Apache Hadoop clusters. Then we have Avro. Avro is for data serialization of the system. Then we have Cassandra, which is also, we can say it is for the data storage layer. So it is a scalable multi-master database, and it does not have any single point of failure. Then we have Chakwa, which is a data collection system for managing large distributed systems. Then we talked about Edgebase and Hive. Then we have Mahout. Then we have Pig. Then we also have Spark. Spark is a fast and general compute engine for Hadoop data, and it provides a very simple and expressive programming model, and it supports a wide range of applications such as ETL, machine learning, stream processing, graph computations, etc. Then apart from that, we have TASE, that is TEZ, TASE. So what it does is it performs a generalized data flow programming framework, and it is a generalized framework which is built on top of Hadoop Yarn, and it provides a very powerful and flexible engine to execute an arbitrary DAG. So DAG stands for Directed Acyclic Graph of tasks to process data for both batch as well as interactive use cases. Apart from that, we have Zookeeper. So these are the different supporting tools and libraries which are present, which run on top of Hadoop. So now we will stop here for a short break, and after the break we will be discussing more on the Hadoop paradigm, and what are the different, we'll be studying the different components of Hadoop also in detail. So we'll just stop here.
Dear viewers, we'll be back after this short break to continue with this lecture. Hello viewers, welcome back to this lecture on Hadoop architecture. We have spoken about all the projects that are going on in this Hadoop architecture. So we welcome you back in the studios. Welcome back Dr. Shakir, and we proceed with the second part of the lecture.
Hello, so we just talked about the different technologies and other related projects of Hadoop. Now we will be discussing in detail about the Hadoop architecture and the different components of Hadoop. So basically Hadoop skill set, it requires a very thoughtful knowledge of every layer in the Hadoop stack. So we need to understand about the different components in the Hadoop architecture, and we need to understand how do we design a Hadoop cluster, and how do we do the performance tuning of the cluster, then how we will be doing this setting of the top chain, which is responsible for the data processing in the Hadoop architecture. So this figure, it shows the high level architecture for Hadoop. In this, what we have is, we have two different layers of Hadoop. As we talked about the different components of Hadoop, out of the 4 components, these two, HDFS and MapReduce, they are the basic building blocks of Hadoop, we can say. So in case of HDFS layer, we have one name node and we have different data nodes which will be coordinating with this name node. So it is a kind of master slave architecture, we can say, where different data nodes, they will be working depending upon the commands of the name node. Then in case of MapReduce layer, we have a task tracker, we have a job tracker, and this job tracker will be keeping track of the different task trackers. They will be subdividing the jobs in the MapReduce paradigm into different tasks, and each of the tasks will be handled by the different task trackers. Apart from that, we will be having a master node and we will be having different slave nodes. So job tracker will be the master node in case of MapReduce layer, and in case of HDFS, we will be having one master node in terms of the name node. So like we just talked about, that Hadoop follows a master slave architecture for data storage using HDFS and for data processing using MapReduce. So the master node which we just talked about, the master node for data storage in Hadoop HDFS is the name node, and the master node for parallel processing of Hadoop MapReduce is the job tracker. And the slave nodes in the Hadoop architecture, they are the other machines in the Hadoop cluster. What these machines do is, they store the data and they perform any kind of complex computations and other kind of processing. So all the processing and all the computations will be done by the other machines which are connected by the master node to the slave nodes. So the slave nodes will be performing all the processing part, and the master node will be giving the instructions about what particular processes needs to be done, processed. So every slave node, they will be having a task tracker daemon and a data node which will keep on synchronizing the different processes which are taking place between the job tracker and the name node respectively. So now let's have a look at one of the typical use cases of a Hadoop cluster. So what a Hadoop cluster is? A Hadoop cluster is a special type of computational cluster which is designed specifically for storing and analyzing a very large amount of data, and this data is usually unstructured in form, and this data is analyzed, it is stored, it is processed, it is retrieved in a distributed computing environment. So for making this cluster, we need certain configurations of the different nodes. So we have a secondary name node which has around 32 GB of RAM, 1 TB of hard disk, and the processor for this should be around 4 cores. And apart from that, we need an Ethernet connection. Then we have active name node. So the concept of active name node and secondary name node, it came about in Hadoop architecture, from Hadoop 2.0 onwards. And for active name node, we need a higher RAM configuration. Then we need a hard disk, say for about 1 TB of hard disk. And apart from that, we also need a machine which will work as the standby name node. Then all these name nodes will be connected. The active name node will be connected to the different data nodes. These data nodes are the ones where all the processing will take place. So the configuration of these data nodes, they are slightly less than the name node. So it is since we said that Hadoop, it works on the commodity hardware. So the configuration for the data node will be slightly lower than the active name nodes. For example, if we have an active name node with a RAM of around 64 GB, the data nodes will be having RAM of around say 16 GB each, and hard disks which will be 6 into 2 TB. So it will be the storage will be more, but the RAM will be less. And in case of name node, the RAM will be of higher configuration and storage will be less than the data nodes. So Hadoop, the cluster architecture for Hadoop 2.x is also known as HDFS v2, as it is part of the Hadoop 2.x architecture, and it has certain advanced features in comparison to the earlier versions of Hadoop, and it is used as a distributed storage system in Hadoop architecture. So in this we have the master node, then we have, this is not BAME node, we have name node rather, and then we have different resource managers. So whenever the master nodes, the name nodes, they are up, you can know the status of these by clicking these URL HTTP master on the port 40060. Then apart from that, all the remaining ecosystem of the Hadoop component, they will work on top of the HDFS, they will work on top of Yarn, they will work on top of MapReduce. So for example, if a client wants to access the data, then it will be using HDFS. So for that, it will be contacting the name node, and this data node name node will be connected to different since it is we say Hadoop distributed file system. So the data will be distributed on different data nodes, and each of the data node will also be having a node manager associated to it, and this node manager will directly contact the name node in terms of in case of any failure, or in case if they want to communicate any other information, any kind of metadata, anything that will be done by the node manager which is present at the different data nodes. And for resource management part, we have Yarn, and just like the HDFS, here also we have different data nodes and the different node managers. Apart from that, we also have different data managers also for management of the resources. So Apache Hadoop 2.x, it consists of certain, like we talked about just recently, that it consists of certain improvements over the previous version of Hadoop. So previously we had versions like Hadoop 1.x, which was the earliest version. Then we had Hadoop 2.0, which had the concept of federation. So what federation does is it allows multiple name nodes. In this federated architecture, multiple name nodes are present and they are federated together, that is, they are independent from each other. So we have multiple name nodes, and each of these name nodes, they are independent from each other in case of Hadoop 2.x architecture. When we will consider, if we consider and have a look at the architecture of Hadoop 1.0 and the architecture of Hadoop 2.0, we can see that the storage in both of them is a common storage, but we have multiple independent name nodes in case of Hadoop 2.0 architecture. Then Hadoop 2.x, it also ensures very high availability of the nodes. How it does is, one of the cases by which it can be done is by replicating the data across different data nodes. So if one of the node it goes down, then another node it will automatically go up. So in case of if a client wants to perform any kind of read edit logs, or it wants to perform any other kind of operations, what it does is the client, it issues a request So all the namespace edits, all the logs to the shared NFS storage, etc. will be done by the client via an HDFS. So when a request goes, the request will go to the active name node, then active name node will search for the data node for which the request is targeted at, and then we also have node manager, like we just talked about, that each data node will be having a node manager associated with it, which in turn has a container and an app master. So all the request, it goes via active name node and it reaches the data node, and then when the request is fulfilled, it goes back and whatever is the requirement or whatever is the processing is done, and it goes back to the client itself. And similarly, we have yarn part of Hadoop 2.x architecture, which we can say it ensures high reliability, and we did not have the concept of secondary name node and a standby name node in Hadoop architecture 1.0. This also ensures a very high availability, and yarn also ensures a very high availability, and it manages the resources using an entity called as the resource manager, which manages the resources which are present on the different nodes in the Hadoop architecture using the node manager, which runs on top of the data node manager. Apart from that, like we just discussed, whenever the client makes a request, this request goes through the active name node, and in case there is any write operation, this information is also shared by the different edit node, edit logs, and a replica of the whatever is taking place is kept in the standby name node. So whenever the active name node it goes down, the standby name node it comes up. So we can say that the standby name node in this case is ensuring a high availability in the Hadoop architecture, that in case even if the active name node it goes down, then the standby name node it can work and it can go up and start working. So after the request is passed from the active name nodes, the request is sent to the different data nodes. These data nodes are present on the different machines which are working in parallel to provide in the Hadoop paradigm. So this data node is, we can say that each of the machines which are connected in parallel, which are part of the Hadoop cluster, we can say that some of the machines they are data node, then one of the machines we will keep it as an active name node, and another machine, in order to ensure high availability, we will keep it as the standby name node. So in this case, the active name node, the standby name node, they will act as the master through which all the commands of the client will be issued. They will be sent to the different data nodes. All the processing and all the other activities will be taking place at the different data nodes, which will be acting as the slaves. And when all the processing is done, all the consolidated results will then pass to the name node and then reach the client. So we henceforth we have a master slave architecture where the name node acts as the masters and the data nodes they act as the slaves. So the resource management in Hadoop 2.x, how that is handled by the yarn, this by the yarn part of the Hadoop architecture. So here also just like the HDFS part, whenever any request comes, yarn is basically for management of the resources in the Hadoop cluster. So just like we had node manager in case of HDFS, here also we will be having node managers which are located at every data node of the Hadoop cluster. So whenever a request comes up, it will go through the resource manager. Resource manager will perform all the scheduling activities, like which processing will take place at which data node. So all the scheduling activities will be done by the resource manager. All the application management activities will also be carried off by the resource manager itself. So here the resource manager, in this case in the yarn part, will be acting as the master, which will be connected to different data nodes, and in each of these data nodes we will be having different node managers, which will be sending all the information regarding the data nodes to the resource manager. So here also we follow a master slave architecture in both the HDFS part, where the processing and all the other activities were taking place, and even in the resource management part, which is the yarn architecture. Here also the architecture is master slave, but the only difference is that part is taking care of the data storage and retrieval. This part is taking care of the management of the resources. So here the resources in this case will be the different computers which are connected to the resource manager, that is the different computers which are acting as the data node. So Hadoop, we have been talking about Hadoop clusters, but it is not necessary that Hadoop will work on a cluster of machines. It is not necessary that you need say like 5 or 6 machines to run your Hadoop framework. If you want, you can run Hadoop even on a single machine. So this kind of so we have different modes of operation of Hadoop. First is the standalone, or we call it as a local mode. In this mode there are no daemons. Everything will run in a single Java virtual machine, and it is basically for those users who want to run their MapReduce programming, and if you want to test whether your MapReduce framework is working well or not. So just for, you can say it is just for testing purpose, that whether your MapReduce program is working fine or not. In that case you will go for the local mode of operation, and in this mode we do not have any distributed file system. It will work like your normal machine, but the only difference is now you will be able to run your MapReduce program. So you will get a feel of how parallel processing is taking place. Another mode is pseudo distributed machine. In case of pseudo distributed machine also, we have a single machine which is running all the entire Hadoop framework, but the difference here is that we also have the Hadoop daemons. In case of standalone mode, we did not had any Hadoop daemons running, and everything was running in a single Java virtual machine. In case of pseudo distributed machine, we have the Hadoop daemons also running. Then the third mode of operation of Hadoop paradigm is fully distributed mode. So when you want to have a if you want to have a look and feel of how the actual cluster works, how the actual parallel processing works, then you should go for fully distributed mode. But in this case you will be needing a lot of machines. You will be creating a cluster of machines, and on these clusters you will be running your Hadoop daemons, and you will be running your yarn, which is the resource manager, so that you know that how are the resources being managed. So you will be needing in the cluster, you will be needing to keep one machine as the node manager and the other machines as the slaves or the data nodes, and on the top of them you will be running your yarn for resource management activities. Then you will also be having a distributed file system also. So fully distributed mode is for the actual development environment, for knowing that how the actual MapReduce programming paradigm is being used. So if you just want to test the programs, you should go for standalone mode. If you want to have a feel of how the Hadoop daemons will run, then you should go for pseudo distributed mode. And if you want to have a real life feel of what Hadoop cluster is, then you should go and install fully distributed mode. But for this you will be needing a cluster of machines, you will not be needing just a single machine. So as we just talked about, that Hadoop, it has 3 deployment modes: local standalone mode, pseudo distributed mode, and fully distributed mode. So in the fully distributed mode, all the components of Hadoop, such as name node, the data node, the job tracker, the task tracker, they will run in a single Java process in a local or in a pseudo distributed mode. So now let's look at these modes, different modes of operation of Hadoop in a little more detail. So standalone mode, it is so by default what mode we have is the standalone mode. It is the default mode, and we should use it if we do not want to configure anything else. So in this mode, we have all the components of Hadoop. We have the name node, we have the data nodes, we have the job trackers, we have the task trackers, but all of them, they will run in a single Java process, and we will not be having any active daemons in this kind of mode. In case of pseudo distributed node or a single node mode, it is the single node Hadoop deployment. It is also considered as a running Hadoop system, but on a single machine. It also includes all the masters and slave things. All the job trackers, name node, etc. will work on this, but they will all be executed on a single machine, and all the Hadoop daemons will also be executing in this mode. This kind of environment is used basically mostly for testing purpose, for fast testing of applications, where we are developing these without having to think about using the actual Hadoop cluster. Then it is also an easy way for experimenting with Hadoop. So for those who want to learn Hadoop and they do not have a cluster of machines, then they should go for pseudo distributed mode, and who are already familiar with the Hadoop environment and they just want to perform some kind of testing purpose, then they should go for the single distributed mode or the local distributed mode. And those who want to have the entire look and feel of Hadoop, they should go for fully distributed mode, in which Hadoop master and slave services, they will run on separate cluster of nodes, and since they are running in separate cluster of nodes, we call them as a fully distributed mode. So it is a perfect mode for production and development of clusters, and using this mode we can make any kind of distinctions such as about the development of the clusters, because generally we have lesser number of nodes, and it is for building a kind of prototype of the workloads that will finally run on the production cluster. So if you want to test how it will run on if you want to learn how Hadoop works in a fully distributed mode, what you can do is you can just make a cluster of 3 or 4 machines and then see how actually the production works, and then if you're working on some project, then you can run it on the actual production cluster. So there are many important configuration files which are present in Hadoop 2.x. First is the Hadoop env.sh file. This file, it comprises of all the different environment variables that are used in the scripts to run Hadoop. Then we have core-site.xml, which contains configuration settings for Hadoop core, such as IO settings that are common to HDFS and MapReduce. Then we have HDFS site.xml, which is for setting HDFS daemons, and then for setting the name node, the secondary name node, and data nodes. So on which port HDFS daemon will function, then how the name node, secondary name node, all the configuration informations will be present in HDFS site.xml. Then we have MapRead site.xml. So any configuration settings for MapReduce application will be done at the MapRead site.xml. Then we have yarn site.xml, which is for making any configuration settings regarding the yarn cluster and that is the resource manager and the node manager of the yarn. Then we have the master node, which will take care of all the machines that run each run a secondary name node. So all the information regarding that what all machines will be running secondary name node, then which node will be the master node, all this information will be present in the master file. Then we have slave files. It will contain configuration information about the slave machines and which node will be acting as data node, and then the information about the node manager. So all this will be present in these slave files. So so summing up about the different configuration files, we can say the configuration file for containing all the core information is the core site.xml. For HDFS related information is the HDFS site.xml. For yarn related information is the yarn site.xml, and for making any kind of configuration settings relating to MapReduce paradigm, we have MapRead site.xml. So whenever we said that Hadoop, it comprises of master slave architecture. So there are two files that are used for maintaining this architecture for startup and shutdown commands. So for slave, we have the slave file, which contains a list of all the hosts and all the hosts that will be hosting the data nodes and the node manager server. Then we have the master file, which will contain a list of hosts that will act as the secondary name node server. So then Hadoop env.sh, we said that it will be configuring the environment variables of Hadoop. So using Hadoop env.sh, we can set up the environment variables, such as we can set up the parameter value for Java_home environment variable. So this file, it also offers a way to provide custom parameters for each of the server. So for example, we can set up different apart from just setting up the Java home, we can also set up other environment other variables relating to Hadoop, such as the heap size of Hadoop. So if you want to set up the heap size of Hadoop to a particular value, what you can do is you can just use the command example export Hadoop_heap size, and if you're setting it as 512 equal to, in the brackets you can mention 512. Then you can also change the data node heap size. So if, for example, if you want to change the data node heap size to 128, you can just use the command export Hadoop_data node_heap size equal to 128. Hadoop, it also has a passwordless SSH. So in Hadoop, a distributed Hadoop cluster setup, it requires SSH based key authentication, so that the master node can log in and it can start, it can stop the various daemons, etc. So before logging into the master node, you need to perform SSH key based authentication. and if SSH is not passwordless, we say that SSH in this case is passwordless, because if SSH is not passwordless, you would have to go to each of the machines, and then you would have to start the daemons, start the machines manually. So that is the reason why Hadoop cluster, it offers passwordless SSH, so that all the machines, they can be started off automatically without the need for going and starting each of the machines connected in the Hadoop cluster manually. So that is the reason why we have a passwordless SSH in the Hadoop cluster. So we can use these SSH to launch the server processes on the slave nodes, and it is basically required for performing any kind of connections between the master node and all the slaves and the secondary name nodes. So we have discussed about, till now what we have discussed is, we have discussed about the Hadoop architecture in detail. Then we have discussed about what is the difference between Hadoop 1.x architecture and the Hadoop 2.x architecture. Then we discussed about how machines are launched automatically using passwordless SSH. Then we also discussed, just in the beginning we had discussed about 4 major components of Hadoop. That was the utilities, then we talked about yarn, then we talked about HDFS, then we talked about MapReduce programming framework. So out of all these components, 2 of the components, they are very important, and they were present since the earliest versions of Hadoop, that is Hadoop 1.x. These components are the Hadoop distributed file system and the MapReduce parallel processing framework. So in the upcoming lectures, we will be discussing these 2 components in detail. That is the Hadoop distributed file system we will be studying in detail, and also we will be talking about MapReduce programming paradigm in a lot of detail in the upcoming lectures. Why we are talking just about these 2 components, because they are just the basic building blocks of the Hadoop paradigm. So in fact, HDFS we have also discussed in a previous series on cloud computing, but in regards to big data analysis, we will be focusing more on the HDFS part, because big data, it comprises of a huge amount of data, and it is not possible that you will store this data on a single machine. So you need to store your data in a distributed manner across a cluster of machines. That can be achieved through the Hadoop distributed file system paradigm. And since the data is huge and you cannot process this huge data on a single machine, so for processing also of this data, we need multiple of machines which can process in parallel using the MapReduce paradigm. So now we will be stopping here for today, and in the next lecture we will be discussing about the other 2 components. I hope by the end of this lecture you are familiar with the Hadoop ecosystem and the Hadoop environment. Thank you so much.
Thank you, Dr. Kashish. This was a very elaborate lecture in which discussed all the components of Hadoop, and I'm sure listeners, you will be having some queries, so why don't you write into us at the email address, and also you can call us at 1-800-110-430 as a toll-free number, and you can put across your queries. So till next time, thank you viewers. Thank you, Dr. Kashish.
Thank you.